Safe Software, the company behind FME. My background is in GIS, geospatial data. I've got a passion for cartography as well. I freelance as a cartographer as well. I've been using FME throughout my career for over 12 years. I've worked across the UK, New Zealand, and now Canada. So apologies for my accent. It's kind of a bit all over the place, but hopefully I'm understandable. So the plan for my presentation and demonstration, I'm going to start with a bit of an overview of the FME platform so that we're all on the same page about what FME actually is. Then I'll introduce FME Form, which is where you author your workflows in our Workbench app. From there, I'll touch briefly on the ArcGIS data interoperability extension, which brings the power of FME directly into Esri products. And after that, we'll switch over to FME Flow, which is really the heart of today's presentation. Flow is where your workflows come to life with automations, schedules, self-serve web apps, and all sorts of others. And I'll be running live demos throughout, and hopefully they will work. I have tested them. I hope the firewall isn't going to play havoc with some of them, but we'll see. So what is FME? We bill FME as the only all data any AI platform. So what does that actually mean? At its core, FME is a no-code platform that integrates any data source, has the ability to connect to any AI model, and delivers trusted results. So for those of you working in GIS, which I presume is all of you, FME is a tool to automate repetitive tasks, integrate data across formats and systems, and build powerful workflows, all without writing any code. If you've ever spent half a day exporting data from one system, manually tidying things up, and then importing it somewhere else, FME is the tool that turns that whole process into a single click, or even do it automatically. There's two core components to the FME platform. The first is FME Form, and some of you who've used FME before might remember this as FME Desktop. We had a rename and a rebrand a few years ago, so it's now FME Form. This is the no-code authoring environment where you build all of your data workflows. This is where everything starts. So you build and test your workflows in an application called Workbench using a graphical interface, and you can run translations directly from your desktop. The second component is FME Flow, which used to be known as FME Server. This is the server-side component of the FME platform, and it's where you deploy the workflows you created in FME Form. Once they're on Flow, you can then power them with automations, no-code web apps, and all sorts of other integrations. FME Flow can be deployed anywhere you need it, on-prem, in the cloud, hybrid, containerized, wherever you want. Or alternatively, with FME Flow hosted, you can let us at Safe Software handle the deployment for you, and that's in an Amazon Web Services environment. And we take care of all of the maintenance and backups and everything like that. There is a third component to the FME platform that I won't go into today, and that is FME Realize. This is our augmented reality app that extends the power of FME into spatial computing, which lets you visualize and interact with your data out in the field and harness the power of the workflows that you've built in FME Form and deployed on FME Flow. So for the rest of this session, I will focus on Form and Flow. Just a few quick numbers to give you a sense of where FME sits in the world. So as mentioned, I'm coming to you today from our Surrey headquarters near Vancouver, British Columbia in Canada. And this is where FME was first created over 30 years ago as a geospatial data translation tool. Today, or in the last 30 years, we've expanded somewhat. Today, we've got over 200,000 users across more than 25,000 organizations in over 100 countries worldwide. We also have a very active user community online. We've got over 30,000 members of the FME community forum who post questions, share solutions, submit ideas for software improvements. And so if you ever get stuck and need any assistance, then there's a good chance that someone has already solved either your exact problem or something very similar that you can take their solution and tweak it for your own use. In terms of the industries, FME is used by customers across pretty much every industry that you can think of. Utilities, all levels of government, transportation, architecture, engineering, construction, all sorts. Although FME started out by solving geospatial challenges, and that is still where a lot of our customers come from, FME is no longer limited to geospatial data. If you have data in two systems that need to talk to each other, FME can help regardless of whether that data has coordinates. So on to FME Form, where the solutions are built. This is our no-code graphic interface where you create all of your data workflows in the application called Workbench. This is what Workbench looks like. The main panel in the middle is the canvas, and that's where you actually build your workflows by connecting three types of objects: readers, transformers, and writers. Readers and writers handle your input and output data, and FME supports over 450 different data formats. That includes the obvious geospatial formats, but also non-spatial tables, CAD and BIM data, raster and imagery, 3D point clouds, markup languages like XML, plus also web services, real-time data streams, business systems, pretty much anything. If there's something that we don't support, then we're probably already working on it, or submit it as an idea in the FME community and we will get onto it. So in between the readers and the writers, you have over 500 different transformers to choose from. And these are how you actually interact with the data. You can perform joins, filter on conditional values, spatially relate two or more data sets, create, modify, remove attributes or geometry, anything that you want. Other transformers can connect out to web services like ArcGIS Online, cloud storage, Google Drive, Amazon S3. They can connect to email agents, to Slack, to Google, anything. You can also add annotations and bookmarks to describe your workflow if you want. We bill it as best practice, but I'm very guilty of not doing it myself most of the time. The workspaces that I'll demonstrate today, I have, but that's mainly because I'm presenting them. But it's a very good idea to annotate your workspaces. It makes it really useful for navigating larger workspaces and for explaining what's going on in that workspace, either to your colleagues or to your future self. So when you're ready and when you've built your workspace or you've built your workflow, then you can run the translation right inside the Workbench app by clicking the Run button. With live data caching turned on, you can watch the data flow from end to end through the workflow, and you can inspect what's happening at any point along the way, either in the table view or a map view. And then you can also drill down to the individual details of individual features. So let me show you what that looks like. So this is an example of a workspace that I've built. And the goal is to take a CAD drawing of a water distribution network here in Vancouver and enrich it with information from a couple of other sources, then write it out to a few different formats for different audiences. So on the readers, in orange here, I'm reading in three different data sets. I'm reading in a DWG file, which contains the water distribution mains. And there are a few attributes on there, such as their material code, the diameter, their installation date. And then also reading in a CSV table, and this is just a lookup table of material codes linked to material names. And then I also have a shapefile of suburban boundaries, neighborhood boundaries, and that's a polygon shapefile. So they're the three readers. I then have a series of transformers. I'm just exposing some attributes from the DWG file so that I can use them. So the material code, diameter, and installation date. I'm then performing a join on two different data sets. So on the DWG file and the CSV table, performing a one-to-one join on the material code. So that's going to bring in the material name from that table. I can then do a spatial relation between these features and the neighborhood polygons so that I can grab the neighborhood name and attach that to each of the lines. As well as the readers reading in data sets, I've also set up a user parameter. And this grabs, I've set up several, but the one that will be displayed at runtime is neighborhood. And this is just a drop-down option of all of the neighborhoods that are available in my shapefile. So at runtime, the user can select one of them, and that is then what will be grabbed by a parameter fetcher and then tested against the neighborhood name. And so if the lines have that neighborhood name, then they will pass and keep going through the workflow. Otherwise, that's where they stop. And then finally, an attribute manager, one of the most used transformers in any FME workflow. This is where I'm creating new attributes from existing ones. I can remove unwanted ones. I can adjust existing attributes, such as changing material names to all capitals or all lowercase, things like that. And then finally, I've got three writers. And so these will all write out simultaneously. So I'm writing these features out to an Esri file database for the GIS team, a non-spatial Excel spreadsheet, because who doesn't love a spreadsheet, and also writing back out to a new DWG file. And this time it's going to have the material name and the neighborhood name attached to that as well. So let's see that in action. I will rerun my entire workspace. I'm asked for all of these parameters, and this is the one that is key. So I'm going to select a neighborhood. I'm going to select downtown. I can provide, I've set this up to provide a prefix for my output files, just so I can keep a track of where they go. And then I'm providing where the input files and output destination locations are. So I can click run, and we see translation in progress in the bottom left. And then after it thinks about it for a second, we'll start to see the numbers increasing as all the features from each source are read in. I've got these little green eyes that appear, and so I can click on them, and in the data preview panel at the bottom, I can see the features in a map view or a table view. This is the DWG, so it doesn't have any exposed attributes in the table. But if I look at the shapefile, I can see that it's got an attribute of the name. And if I click on any of the items, it's taking me to their location on a map. As these are progressing through the workspace, we can see that these numbers are increasing, everything's working, the tester is filtering out neighborhoods that don't match and passing on neighborhoods that do match. And then these are passing out to the three different writers that I have. This is quite a big file, so it is kind of taking a bit of time. But once that's done, we've got translation successful. We have a translation log of everything that's happened, and I can see total features written. There's 13,800 of them. That's split across these three different writers, each of those 4,600 features. So the takeaway here is that we've started with just three input files and three different formats. We've performed attribute and spatial joins. We've filtered based on a user choice, and we've written out to three different output formats simultaneously, all without using a single line of code. So that is most of FME in a nutshell. And the rest of it, the rest of the power is in what comes next, which I'll get to. But as an aside, we will talk about the ArcGIS data interoperability extension, which is not easy to say 3 times. So FME Form is a standalone application, as you saw. It can read from and write to all sorts of GIS formats, including Esri formats many of you probably work with day to day. But for those of you who really live in ArcGIS, The power of FME is also available directly within ArcGIS Pro and ArcGIS Enterprise via the Data Interop extension. This gives you a version of Workbench that you can use to create your data translations exactly as you would in FME form, but you run them as a spatial ETL tool directly inside ArcGIS. It is worth noting that this is a separate license on top of ArcGIS, and there are limitations in terms of data formats available and the latest functionality. But if you're a heavy GIS user, then it's a real nice option. So inside ArcGIS Pro, when the extension is installed and licensed, on the analysis toolbar, there'll be a data interop. That's where you can access the data interop extension. You can also access it by creating a new spatial ETL tool inside any of your toolboxes. This works very similarly to creating a scripting tool, but instead of requiring a Python script using ArcPy or similar, you create the tool using the FME Workbench interface. So you're using FME's no-code environment to build your tool rather than writing code. Once you've built your tool, any user parameters you've created in Workbench automatically appear as parameters in ArcGIS when running the tool. So your colleagues don't even need to know it's FME under the hood. From their perspective, it's just another ArcGIS processing tool. So I'll quickly switch to a demo here. So this is ArcGIS Pro. This is downtown Vancouver. Our office is quite a way off to the southeast of this map in Surrey in Greater Vancouver. So creating a new tool, I can go to one of my toolboxes. I can right-click new, and then rather than a model script or a tool set, I now have this spatial ETL tool option at the bottom. So if I click that, it'll bring up a window. I can give a name, a label, a description. I can specify which toolbox I want it to live in. And then on the Workspace tab, it's giving me a path to the actual FME workspace file that will power this tool. So I can either create a new one through here, or I can link it to an existing workspace if I already have one built. And so if I click OK, it'll start running to create that tool. It's not running a tool because I haven't built it, but it's starting the process of creating it. And it will open up the ArcGIS Pro data interoperability extension. The splash screen has appeared on my other screen, but it's an ArcGIS Pro splash screen, but with data interop extension on it. And then when that opens, what it is now doing, this is the very familiar FME Workbench app. And it's asking me to generate a workspace. So if I've got data coming from one format to another, I can select that here, and it will pre-populate a reader and a writer that I can then put transformers in the middle of. Or I can click cancel, and I just have a blank canvas, and I can just start adding readers myself, adding transformers, and building up a workflow. Once I've done that, I can save it, and then that will be linked to my tool back in my toolbox in ArcGIS Pro. So I've already prepared a tool using the same workspace that I just showed you in Workbench. So I'm not going to build one from scratch, but I have this enriched DWG with material and suburb tool. I can double click that, and I'm presented with the same user parameters as I had in Workbench, just this time in the ArcGIS geoprocessing tool. So I can select my source DWG file, I can select my neighborhood from the drop-down, I can specify a prefix, set where my source files are coming from, and where my output files are going to. And then I can just hit run, and it runs as a normal tool in ArcGIS Pro. I can hit view details, and we start seeing the same translation log as I would get in FME if this was running there. As it's processing through, lots of messages. And after a while, that will process, and it will write out to those same 3 data sets that I had when I did the form demonstration. And here we go. We have a few warnings just saying 2D features were found in 3D feature formats. you can set up logging, you can set up messages, you can set up errors so that you've got good oversight of what is happening in it. But then we get to the end, I get the successful total features written. This is the same number as before. I can close that down, and now I can see that in my geodatabase, I've now got a new feature class. I can drag and drop that into the map. And as well as this, if I refresh when it loads, if I refresh my output folder, I've got a new data interop folder because that's the prefix that I specified. In there, I've got the Excel spreadsheet and the enriched DWG file as well. And then the feature class in my file geodatabase, that's in. I can now click on one of these items, and we can see there it's enriched with the material name, it's got the neighborhood name. So that's all from that translation. So the key point of the ArcGIS data interop extension is that it brings the full power of FME, but running natively as a geoprocessing tool inside ArcGIS Pro. So now on to the main course of this presentation, FME Flow. And this is where the solutions are delivered. So this is the server-side portion of the FME platform, previously known as FME Server. And it's where you take workspaces that you built in FME form and bring them to life with automations, no-code web apps, and a whole lot more. So how do workspaces get from form into flow? The first step is that you connect your FME Flow instance inside FME form, and then you publish your workspace. It's pretty much as simple as just logging into your Flow connection and clicking through a publish wizard. Once it's published, you can access it in FME Flow through a browser interface. From here, anyone with appropriate permissions can find the workspace, run it on demand, schedule it, build automations or apps around it. And we'll be doing all of those things in the next few minutes. So, FME Flow demonstration. We'll start back in FME form. So here is a slightly more complex workspace. It has to be zoomed out to see all of it on one screen. But basically, it takes one of those same DWG files as we had before as a reader, and then it performs validation checks on the attributes and the geometry against pre-populated rules. And then finally, towards the end, this large section generates an HTML report stating whether the DWG file has passed or failed validation. It'll give the features on a map in the HTML file, and if it's failed, it will also give a list of the features that have failed and the reasons for them failing. So FME Flow has a few standardized directories relative to its install location, and these can provide homes for various items like temp files, input-output files, and dashboards. In this case, I've specified in this workspace that the output HTML file, which is here, I've specified that this is going to be written to my FME shared resource dashboard folder, and then a subfolder called dashboards within that. So if I'm running this on my desktop through Workbench, I need to specify a folder anywhere that it's going to replace that with. When I run this on Flow, it already knows where this FME shared resource dashboard folder is, and so it will write it straight to there. And then I can view it in a different part of the Flow interface where I can see all of my dashboards. So I can run this locally just to demonstrate what happens. Don't worry about that error. That is just a slight bug that we've got with one of our transformers that, even though it works perfectly fine, it still flags up an error. It's been fixed in a latest release. So I'm specifying a new DWG file. This one has got the word errors in it because it definitely has errors in it for the purposes of this demo. And then I'm specifying that it's writing out to that dashboards folder. So I can hit run, and when we go back to the beginning, after it starts reading in, we'll start to see the features flowing through. It's splitting into two parallel streams. One checks the attributes, one checks the geometry. It then recombines them, populates various attributes, splits into valid or invalid features, and then the large section creating the HTML report. I'm told translation successful. It's all completely finished. So on the output, I can go to my dashboards folder, and I've got my validation report that has been created in there with the current timestamp. This is in Pacific time at the moment. And so I can open up, excuse me, I can open that up and see the validation report that it's created. So I can see that this file has failed. 22 features out of 852 have failed. This is where they are. And then I've got a table of reasons for failing. So we don't need to concern ourselves too much about the data itself, but just a demonstration of the report that's been created from running it in Workbench. Now I want to use the power of Flow to automate this. So first I need to publish it there. So on the toolbar up at the top, I've got my FME Flow connection. I've got a local instance on my laptop, and then I also have one of our FME Flow hosted instances as well. For this, I'll publish it to my local. I can just hit publish, and then I can select a repository where I want to upload this, give it a name. It'll default to the current name of the file. I can hit next, and then I can select which service I want. I'll go into the services a bit later, but Job Submitter is the default one. I'm going to select data streaming for this one as well. And then I can just hit publish, and it will publish it to my Flow instance. I've already done this, so I will click cancel. And so in FME Flow now, we can see that we have in my a repository called Water Network Demo, I have this FMW workspace file. I've got the Job Submitter service for it, and the user parameters that I've set up. All I need to do is upload an input DWG file. I can also specify a different destination for the HTML file, but I will leave this as the default. So I can upload a DWG. I forgot to prep where this was. Apologies. Just 1 second. Let me just find one. I prepped everything else apart from where this file was. So here we go. I will drag and drop a DWG file in. Hopefully, there we go. So it's uploaded a DWG file to Flow. I can then hit run. It'll run and hopefully complete. I could view details of the job. If it fails, I can view the logs. But this has said translation successful. I've got a job ID. It's written one feature, which is that HTML report. And then I can go to the dashboards section of my FME Flow instance. And let's go through here. So through jobs, dashboards, and I now have this dashboard in there. This one again has failed the validation, and it's given me where the failed features are. It's given me the table, and this is hosted within FME Flow rather than in a folder somewhere that I need to then go and find. So that's the same workspace as before, but now running on the server and with the output stored in a known location that I can come back to later, or that any of my colleagues with the access to that Flow instance can also go to. So that's great, but I still have to run the process manually each time I have a new DWG file to validate. And that's the kind of repetitive task that I really don't want to be doing every day. And this is where automations come in. An FME Flow automation is how you run a workflow automatically based on some kind of trigger. Automations are built in a similar way to workspaces in Workbench. It's a graphic interface where you connect triggers to actions to create automation workflows. Triggers can be all sorts of things. A schedule, a new file appearing in a directory or in cloud storage like an S3 bucket, an email being received, a webhook being called, all sorts. Actions include running workspaces and logging messages, but also external actions like sending emails, making HTTP requests, or uploading to web storage. Automations aren't limited to running a single workspace either. You can run workspaces in series or in parallel to build complex conditional workflows. So let me show you a couple of examples. Let's go to here. So this is a very simple automation. It is just a trigger running a workspace. And that workspace is the same validation report workspace that we just saw. So the trigger, in this case, I've specified to watch a resource or network directory. I've specified one of the FME shared resource folders. So because I'm running this on my local system, that is just one of my directories that I can access through Windows Explorer. If this was hosted on an external server, then it would be a network address on there. And so what this is doing is just watching that folder for any create events, and it's polling it every 10 seconds. You can set this to any interval that you want. You can set it to not just watch for create events, but delete events or modify events. But I just wanted to see when a new file gets added. On the workspace side that this is linked to, I've set the workspace file to be my validation report file. And then as the input parameters here, I've told it to take the file path of what it's found in the trigger and use that as the input file. I'm using the default dashboard destination file as well, so that it will run right out to my FME Flow dashboards. So I can then upload a new DWG file to my network location. This is just a shortcut that I've set up to my FME Flow resources data folder that it's watching. And let's add a new one to there. So firstly, copy it into here, and now I'm going to copy it into that network folder. I can go there and see that Kerrisdale has now appeared. So hopefully, if I come back into my automation in FME Flow that is running, when you're building it, it won't be running. You have to start it. Mine's currently running, but in debug mode. So I can click refresh. We've now got a number 1 that's appeared there. So one message has passed through from the trigger that's watching that directory. It will have passed that into the workspace. The workspace will have run. And so excuse me, hopefully I can now go back to my dashboards folder, and if I refresh this, then we now have 2 dashboards available, and I will go to the one with the timestamp of most recent. Here we are. This is the Kerrisdale DWG, another one that has failed. Funnily enough, all of these have got built-in errors into them. So that's now I no longer need to manually run the workspace. All I need to do is just drag and drop DWG files into a folder and then keep an eye on the reports as they appear. That works well, but it still requires the user to have access to the network directory in order to drop files in, which is not always practical, especially if you want to make this available to people outside of your immediate team or even outside your organization. So instead, I can change the trigger so that the automation monitors an email account. So here is a similar but slightly more complex automation. It's still linear, but the trigger here has changed to an email watch. So SMTP when an email is received. And so if we can have IMAP or SMTP email triggers in FME Flow. The main difference between them is that IMAP is a pull trigger, so it polls the email account at a set interval, whereas SMTP is a push trigger. So as soon as an email arrives, it will know and it will trigger the workflow. You don't need to wait for the next poll interval to arrive. The other difference is that SMTP needs to be, or can only be used when flow is on an externally accessible instance. So hosted on a server that emails can access rather than my local host. So I've now switched to one of our FME Flow hosted FME Flow instances. So this is doing exactly the same, apart from I've added a couple more actions in the middle here. I've got a filter, and this is because emails can have any file attached to them, but I only want ones that are DWG files. So this is filtering out that the email attachment contains .dwg. I'm logging the event just for my records, and then I'm passing this into a workspace. This is effectively the same workspace. I've just set it up slightly differently under the hood, but it still generates the same HTML report, but this time formatted for an email, because when that runs, I can then pass this into an external action. It's another email action, but instead of a trigger, this one is actually sending the email. And so it's going to send that to an address that it's received the email, the original email from. It can CC me in, and then the workspace has generated text for the subject and generated HTML for the email body. So in my email, I can just send an email to the email address associated with my FME or with that automation. I can attach a DWG file to it, and then I can send that email. And then back in the automation, there's one that's already gone through. That's not the one that's that I've just sent. But I can refresh this eventually. SMTP does have a slight delay on it, especially with sort of our firewall and everything like that. But I refresh again, we've seen that there's now 2. So another trigger has happened because it's received that email, and it will be processing that. And then hopefully I can refresh my emails. And this is where it was very hit and miss as to whether this was going to work earlier or not. And it appears that the settings have reset for some reason, but I should be receiving an email out of that. That is an issue with our firewall here in the office. It was working when I was testing this at home yesterday. So apologies for that. Never do live demos. Anyway, so what I've shown with this automation is that now anyone, whether they're an FME user or not, whether they're inside the organization or outside, can get a DWG validated just by sending it as an attachment to an email. Try refreshing once more. No, that's not going to happen. So users don't need access to any system. They don't need any FME knowledge. In this instance, they just need an email address. But using an email as a trigger is just one way to open up the power of FME workflows to non-FME users. And another solution, often a nicer one for end users, is an FME Flow app. Flow apps are no-code apps created in FME Flow and linked to either a workspace or a full automation. Once an app is set up, anyone with the link can access it via a direct URL, fill out the required parameters, and hit run. The behavior that after that depends on the service that you've chosen during app configuration. So this is going back to the services that I briefly touched upon when I was publishing my workspace from Form to Flow. So there's 3 main options: the job submitter service, which runs the workspace exactly as authored without any output data written, with any output data written to whatever locations were specified in that workspace, such as the dashboards directory we saw earlier. Then there's the streaming service, data streaming service, and that sends the results straight back to the user in their browser window the moment the workspace completes from an FME Flow app. And then finally, we have the data download service, which provides the user with a link to download a zip file containing all of the output data sets from that workflow. So I've shown you how the job submitter service works with the first workspace that I showed. So now I'll show you data streaming and data download services in the context of web apps. So FME Flow apps are very simple to create. You come to the Flow Apps tab of FME Flow, hit create, and then you just fill out details, the name of the app, the title of it, the name is required, and this is the machine readable name, so it can't have any spaces. The title is the human readable name. Description, this can be markdown text, so you can provide information to the user about what they need to do, about what the workspace is going, or what the process is going to be doing. I can then select the workspace that I want to run. I can select the service. So in this instance, I want data streaming rather than the job submitter. Data download isn't appearing here because I didn't tick that box when I published this particular workspace to Flow. I can set the security, so if I want it public or if I want it private to only people that have an FME Flow account on my instance. And then further down, we've got options for the parameter defaults. So I want the user to be able to upload a DWG file. So I'm going to have this one ticked to show in the app and not have a default. And then I can also customize the look and feel of it. So I can make it my corporate colors. I can add a browser icon for the network, for the browser tab. I can add a heading logo, footer text, all of these things. So users never even need to know that FME is being used under the hood. It can be really customized. Once I've done that, I can hit create, and it gives me a URL. This one that I've just created is on my local host, so it is a local host URL. No one else would be able to use that. But here's one I made earlier. Obviously, these are the parameters for one that I created, where if I cancel that and go back to where it is, this one, I can open the URL that it gives me. This is on our external one. And so here I have my streaming web app. This is what anyone with the URL will be presented with, as long as it's made public, or if it's private, as long as they have an account to log into. So I've got some details about what the workspace is doing, instructions on how to use it. This is the description from the setup parameters. And then I've got a space where I can upload a file. So I will upload a file. Again, drag and drop, or I can click to browse my file system, or I can browse the resources directory of my FME Flow instance. I can then hit run. That is running in the background, and then straight away, as soon as that's finished, because I've selected data streaming, it directs me to the output. In this case, it is that HTML report. In this case, the feature passed. All of the features in that DWG file were valid for their attributes and their geometry. So I don't have a table of errors. I just have the map and the headline of passed and the number. So that works nicely if, in this case, all the user wants is a report of their data. But what if they want the actual data behind the report as well? So that's where the data download service comes in. So this second app, this one, these are the parameters behind it, but instead of data streaming, I'm now selecting data download. And I've tweaked the workspace itself slightly so that this also now has a shapefile writer in it for both the valid and invalid features. and they will get written out to a zip file. So the front end of this app, excuse me, the front end of this app looks very similar. I've still got my description there. The only difference is that now I'm being told that at the end, I can download the zip containing the HTML report. So I can upload yet another DWG file into here for validation. I can hit run. It's processing in the background. And rather than the report coming up straight away, instead, I'm getting a link to a data download URL. I can download that. That comes as a zip file, and then inside that zip file, I've got my validation report as before. And then I also have a folder with the valid and invalid shapefiles in it. So that's effectively the same workspace, just with the shapefile writer, but under the hood, exactly the same, but with a different delivery mechanism. So you can pick whichever service best fits how you want your users to consume the results. So that was a quick look at what FME Flow can do to help automate your data workflows using automations and flow apps. But there is plenty more in FME Flow that I haven't had time to cover today. But a couple of highlights worth knowing about. Data virtualization. This lets you create REST API endpoints within FME Flow that interact directly with your workspaces. So this means that apps and dashboards that you build externally can connect to the latest data from your workflows on demand without any manual data refresh steps in between. And secondly, coming soon, it's currently in beta, but it will be out later this year. You'll be able to use FME Flow as an MCP server, which turns any workspace into an AI-ready tool. So your existing FME workflows become tools that AI agents can call directly. There's a whole webinar on MCP and how it interacts with FME, both with the forthcoming FME Flow as an MCP server, but also we have a transformer for FME Form that is the MCP caller. So you can use MCP tools that are already in existence, or in the future, even your own FME Flow MCP tools. You can use those within workspaces themselves. So to close out, I just wanted to share some resources that we have. And as I mentioned at the start, the FME community forum is very active, with over 30,000 users posting questions, sharing answers, and submitting ideas for future improvements to the FME platform. And it's one of the absolute best places to get unstuck. If you've got an issue, you're not quite sure how to do something, just Google FME and what the problem is, and it will probably take you to an FME community post or to our knowledge base, which is an extensive collection of tutorials, blog posts, and other resources that we collate and keep up to date as often as we can. We also have the FME Academy for live and on-demand training, and that has all sorts of articles, tutorials, and webinars. The FME Hub is where you'll find custom-made transformers, templates, and connectors built by both Safe Software and by the community, and they're ready to download and drop into your own workspaces. There's all sorts of different custom transformers that do weird and wonderful things that are available to freely download from the FME Hub. And then finally, of course, Safe Software and our partners, we're here for technical support whenever you need it. We can raise support cases. We've got a fantastic team here in Vancouver, and we've got partners across the world, and we're always happy to help. So thank you very much for your time. I'm aware that we are almost at the full hour, but I am happy to take any questions if we have time.